Hello, let's practice solving simple one-step equations. We are on page 17 of our textbook. Let me write it here, page 17. So, solve the equations. Let's just highlight them. A, B, C, D, E, and F. Now, I would like to get away from bar modeling and use the algorithm that we learned in previous lesson. You can check it on the previous video, called isolate the variable. We want to make sure that our variable stands by itself on the left-hand side. Let's remind what left-hand side is. Left-hand side equals to what we have on the right-hand side. So we would like the variable x or k or h to be on the left and everything else to be on the right. So let's work on our equations. X plus 1 equals to 4. Super easy. You don't need to use algebra to solve this one, but we are trying to understand concept, which we can apply to more complicated equations. How do we make x stand by itself on the left-hand side? We must subtract. Let me use a different color. We must subtract 1. We must subtract 1, right? Plus 1 minus 1 becomes 0. That's what we want. X is going to be by itself. What we do to the left, we must do to the right. So now x by itself on the left-hand side, and on the right we have 4 minus 1, which is 3. X equals to 3, of course. 3 plus 1 gives you 4. Equation B. Let's go right to it. K plus 5 equals to 6. I know you understand the answers, but how do we make k stand by itself? We subtract 5 from the left-hand side. Here, 5 will reduce to 0, plus 5 minus 5, right? We use opposite operation. What we do to the left, we must do to the right. So now we have k, I'm going to write it right here. K on the left by itself equals to 6 minus 5, which is 1. Okay, we can say that 6 is the total, k is right here, and 5 is right here. And of course, k must be equal to 1. Now, 2 plus p equals to 5. Again, I know you understand the value of p. These examples are super easy integers, but let's use the same method. We want to isolate p, isolate the variable to stand by itself. P equals, well, how do we isolate p? We must subtract 2. Use opposite operation to get rid of a constant. 2 minus 2 goes down to 0. That's what we want. We have p by itself on the left. What we do to the left, we must do to the right. Subtract 2 from both sides. 5 minus 2 equals to 3. And of course, that is the value. So 2 plus p equals 5. P must be equal to 3. Now, 4 plus h equals to 9. How do we make h stand by itself on the left-hand side? We must subtract 4. What we do to the left, we must do to the right. On the left-hand side, 4 will be eliminated. And on the right, after the equal sign, we have 9 minus 4, which is 5. Of course, here 9 is the sum, and h and 4 are the two parts, and 4 must be equal to 5. We solved this equation. Finally, n plus 3 equals to 5. Let's go ahead, subtract 3 from the left. What we do to the left, we must do to the right. Therefore, m will, by itself, which is what we want, m equals to 2. M equals to 2 is the solution to our equation. 7 plus y equals to 10. We want y to be by itself. What is in the way? 7. We must get rid of it by subtracting it. 7 minus 7 reduces to 0 on the left, plus y, we still have that. And what do we have on the right? 10 minus 7. 10 minus 7 equals to 3. Here is our answer. So these were simple one-step addition equations. Now, let's look at equations that have different operations. 1/4 of x equals to 7. I'm going to write it down. 1/4 of some number quantity x equals to 7. Let's make sure x, how do we make sure that x is by itself on the left-hand side? Well, we see this coefficient of 1/4. How do we get rid of it? 1/4 is the same as x divided by 4. We must multiply by the reciprocal 4 times. What we do to the left, we must do to the right. On the left-hand side, 4 times divide by 4 will reduce to 1, which is what we want. We have x by itself now. Excellent. And on the right-hand side, 7 times 4 equals 28. Let's see if our answer makes sense. If the whole thing is 28, 1/4 of 28, or 28 divided by 4, is that 7? Yes. 28 divided by 4 gives you 7. K divided by 6 equals to 5. I hope you're getting a hang of it. We must make sure K is standing by itself. We want K all by itself on the left-hand side. K divided by 6, how do we make sure we get rid of that quotient, not quotient, divisor of 6? We multiply times 6. We use opposite operation. 6 times K divided by 6 reduces to 1K. What we do to the left, we must do to the right. And therefore, on the right-hand side, we now have 30. K is equal to 30. Here, 30 represents the whole thing. That's your K. And when we divide it by 6, this is our K divided by 6, which is, of course, 5, right? 5. So next, C, 1/5 of, I'm going to highlight it, 1/5 of M equals to 3. I hope you understand 1/5 of what is equal to 3. You might have figured it out on your own, but let's use algebra. In order to get rid of this divisor, M divided by 5, we can rewrite it as M divided by 5 equals to 3. In order to get rid of the divisor, we must multiply, right? It's opposite operation of division. 5 times M divided by 5. The 5s will cancel each other out and reduce to 1. And what we do to the left, we must do to the right. Therefore, M is equal to 15. M is equal to 15. Now let's see. Is 1/5 of 15, is that equal to 3? Yes, 3 equals to 3, right? On the left-hand side, we have 3. So therefore, our equation checks out.